I present to you the velociraptor. Now it's probably a little hungry. You know, it's funny when you think about how simple it always was. All I had to do was take the derivative of a position-raptor. What? Not supposed to work like that. Something about feathers? Something about genetic splicing from amber? Could have sworn I did this right. Huh? Calculus? Uh-oh. I may be a fraud of a scientist who only knows calculus, but I still got a few tricks up my sleeve. You really think I would create a velociraptor with no plan to track its location? Yes? Oh, well, that tracks. Anyways. One here. And one here. The velociraptor has only eaten the goat since I first created it, or about 2,000 calories. On that, it can only run for about 80 meters at its top speed. Using the sensors that I placed, we can figure out how far it's gone and lead it on a merry chase. Then, we'll circle around and catch it when it's gone.
Great idea, Doctor. But wait, your data's all scrambled from the sensors. You have the north and south and the east and west connected. So how are we going to find how far it went?
We will use what I've just discovered I've been studying my entire life. Calculus. We will just have a parametric equation. Two different equations in terms of time.
How did you...
Don't question it. This is how we find the arc length. We take the antiderivative from 0 to 2.5 of the square root of dx dt squared plus dy dt squared times dt.
But we don't have dt and dx, we only have y and x.
Then we'll find the derivatives. You find dx dt, I'll find dy dt.
Well, this thing here says that x is equal to 2t squared minus 3t plus 5. So that would mean that dx over dt is going to be equal to 4t minus 3.
And y is equal to 5 ln t minus 3 plus e to the t. dy dt will be equal to 5 over t minus 3, and then we will add e to the t, because the derivative of e to the t is e to the t. So now we can type these into our calculator.
So what we'll be typing into our calculator is the antiderivative from 0 to 2.5 of the square root of parentheses 4t minus 3 squared plus, and then a parentheses again, 5 over t minus 3 plus e to the t squared, and then all of that times dt. And what does that get us, Doctor?
55.72 meters. So if we subtract that from 80, only 24.27 meters that we left have to run. Get excited, because this is 10 billion% gonna work.